Hello everybody, welcome back to General Science. Last time we talked about forces and how they create motion. Today we're going to talk about other things that have to deal with forces and kind of how we're able to create a force. So we're going to be talking about work, energy, and power today, all three very important classical physics concepts. We'll start off with work. Work is a measure of energy transfer. So it's kind of measuring how much energy can be used over a distance. So for instance, let's say I was trying to push a heavy box across the floor. I would need a force to make that box move, right, to create that motion. And then the distance that box traveled is what's called the displacement. It's how far it moved across the floor. Work is really just the force times the distance that I moved it with that force. That's how much work I did. That's the measure of how much energy I had to transfer to that box to move it to that new place. The unit for work is joules. It's a new type of unit that you might not have heard of yet, but it's an important one. Moving on to the next one that I talked about earlier is energy. Energy is just the capacity to do work. So in the last one, right, we talked about how work is applying a force over a distance. Energy is the capacity to do that, so the ability to move something over a distance using a force. And there's really two main types of energy you're going to focus on in an introductory physics course. There's kinetic energy and potential energy. Kinetic energy is the energy of motion, so things that move have kinetic energy, while things that have the potential to have energy, so maybe something that's really high up on a shelf has a lot of potential energy because it has the potential to fall and release that energy, right, to move quickly. That's called potential energy. Now, finding those two things is different because they're two different types of energy, right? For kinetic energy, you can find it by multiplying the mass of an object times its velocity squared, and then you have to half it, and that's the kinetic energy of an object. Meanwhile, potential energy, especially for the example I gave of something on a high shelf, would be the mass of the object times the acceleration due to gravity, which is 9.8 meters per second squared on Earth, times the height, so how high is it up on its shelf or wherever it is. And that is also in joules. Energy is also recorded in joules. It's the unit for both work and energy. Now, the final thing we needed to talk about then to kind of talk about this whole concept of energy is power. And power is how much work you can do over a set amount of time. So it's really the rate that work is done. Okay? Power is measured in watts, and it's called watts because James Watt invented the steam engine, which can do a lot of work really quickly, right? It can generate a lot of power and do a lot of work over a short amount of time. That's the reason it's called a watt. So these three things are very important in physics, especially when we're talking about classical physics, right? Because they really detail how it is we're able to create forces and make motion, right? So all the things that we talked about earlier when we were talking about motion, like how do things move, and then when we talk about forces, the why things move, is all because of energy and power, right? Your ability to use energy to create work and then apply those forces to make things move, right, all come from work, energy, and power. So it's kind of like the thing that brings it all together. Next episode, we're going to move on to a new topic in classical physics, and I can't wait to talk to you about it. See you soon. Have a great day.